Bismillahirrahmanirrahim. Assalamu alaikum student. How are you? I hope that you will be fine. Today topic is mole and its calculation. Before going to discuss mole and its calculation, you are requested to please subscribe our channel and click the bell icon so that you can get the notification of the new video on the time. Now we move onward toward the mole. What is mole? The gram atom, gram formula unit or gram molecule is called as a mole. Are the atomic mass of an atom, molecular mass of a molecule, and a molar mass of a empirical formula when expressed in gram is called as a mole. Now we move onward toward gram atom. The atomic mass of an atom expressed or taken in gram is called a gram atom. For example, carbon has 12 gram, 12 AMU atomic mass. When it is expressed in gram, then that is called as a gram atom, and so on. Oxygen is, so carbon has 12 gram, and oxygen has 16 gram, etc., etc. Now we move onward toward the gram molecule. The molecular mass of a molecule expressed or taken in gram is called as a gram molecule. For example, water has 18 AMU atomic mass. When it is expressed in gram, then that is called as a gram molecule of water. So water has 18 gram and glucose has 180 gram, etc. Now we move onward toward the gram formula unit. The formula mass of an empirical formula taken in gram is called, for example, sodium chloride has 15.5 AMU mass. When it is expressed in gram, then that is called as a gram formula unit of sodium chloride, etc. Avogadro number. The number of particles, it means that atom, molecule, ion, or formula unit present in 1 mole of a substance is called as a Avogadro number. The number of particles present in 1 mole of a substance is called as the Avogadro number. It is denoted by Na, and its value is equal to 6.023 into 10 raised to the power 23. It means that 1 mole of any particle contains Avogadro number of particles. For example, 1 mole of oxygen contains 16 gram of oxygen and is equal to 6.023 into 10 raised to the power 23 atoms of oxygen, and also 1 mole of water is equal to contain 18 gram of water contain 6.023 into 10 raised to the power 23 molecules of water. 1 mole of sodium chloride contains 58.5 gram of NaCl and contain 6.023 into 10 raised to the power 23 formula unit of sodium chloride. 1 mole of hydrogen ion contain 1 gram of hydrogen ion contain 6.023 into 10 raised to the power 23 ions of hydrogen atom. Note from the above discussion, we concluded that mole doesn't depend upon the quantity, but it depends upon number. Mole is just a counting unit and is equal to Avogadro numbers, i.e. 6.023 into 10 raised to the power 23. What is mole calculation? There are 3 types of mole calculation. One is mole mass calculation, second is mole particle calculation, third is mole volume calculation. Number of moles. If number of mole is required and number of particle is given, then molar mass is also a constant number, so we can easily find out the number of moles. Second formula is derived from the first one. If mass of a particle means atom, ion, molecule or formula unit. If mass of a particle is required and mole is given, then we can easily find out the mass of a particle. So now we move onward with how we can find the mass of a particle. Mass of a particle is equal to number of mole into molar mass, which is also a constant number. As molar mass is a constant, mole will be given in equation and mass of a particle can easily be found out. Note, when mass is given in mu, then mole can be found out by this formula. If moles is required and mass in mole is equal to mass in AMU multiplied by 1.6 into 10 raised to the power minus 24 divided by molar mass in gram per mole. So by this formula we can easily find out moles if the mass in AMU is given. Second number is mole particle calculation. Mole particle calculation can be easily solved out by this formula. So first one is about mole. If mole is required and number of particle is given, then we can easily find out number of mole, because Avogadro number is a constant number and number of particle is given, so we can easily find out number of mole. The second equation is the number of particle is required, number of mole is given, and this is also a constant number, which is Avogadro number, called as equal to 6.023 into 10 raised to the power 23. So we can find out number of particle. We can find out number of particle if mole is given by this formula. So it is find out if number of particle is required, mass is given, Avogadro number is given, and molar mass is given. These two are constant number. So we must have mass in gram which is given, and so we can easily find out number of particle by this formula. Number of particle is equal to mole into x into 6.023 into 10 raised to the power 23. Now what is x? Where x is the coefficient of atoms, ions, bonds such as hydrogen bond is electrons, protons, etc. present in an atom's molecules are formula units. So the third one is mole volume calculation. First equation is about mole. If mole is required, volume is given in dm cube or later. Volume is given in dm cube or later, and moles is required. As we have a molar volume which is a constant and at STP and equal to 22.4 dm cube or later at STP, so it is a constant number. This will be given and this is required. We can easily find out moles by this formula. Second one formula is derived from the definition of concentration. We can also find out moles. We can also find out moles by this formula using volume and concentration. So moles is equal to volume into concentration. So by this formula we can find out the number of moles. Question 3, volume is equal to number of mole into molar volume. We can easily find out volume by multiplying number of mole with molar volume. So it must be noted that in this case number of mole will be given, molar volume is also a constant number, and volume can easily be found out. Number 4, this formula is derived from equation number 3. In number 4, volume is required if mass is given in gram multiplied by molar volume divided by molar mass in gram per mole. In this case, mass, molar mass and molar volume, which is a constant, is given and volume is required. So we can easily find out by putting the value of mass which is given, molar volume which is constant at STP, and molar mass which is also constant for a given gas. So we can easily find out volume by this formula. The molar volume of a gas at STP is equal to 22.4 dm cube, while the molar volume of a gas at RTP, room temperature and pressure, is equal to 24 dm cube. At STP it is at standard temperature and pressure it is equal to 22.4, and at room temperature and pressure it is equal to 24 dm cube or later. Now here are some important conversions which must be keep in mind while doing stoichiometry calculation. So 1 dm cube is equal to 1 liter, 1 centimeter cube is equal to 1 milliliter, and 1 dm cube is equal to 100 milliliter or centimeter cube or cubic centimeter, and 22.4 liter is equal to 22,400 milliliter at STP. Thanks for watching.